Let's continue with the final review. Let f of x equals this, and g of x equals this one. For A, find the inverse of f of x. Escape button to remember the steps of find the inverse function. First step, exchange x, y. F of x, that's y. So we get x equals log base 9 of 6 roots of y. Then we solve for this y. We change argument into exponential form. So we get the y to the 1 over 6 power. Then we do the circle change logarithm into exponential form. We will get 9 to the x power equals y to the 1 over 6 power. Then both sides do the 6 power so that we can solve for y. Y equals 9 to the 6x power. So we get last step, change y into inverse symbol. Inverse of f of x equals 9 to the 6x power. For B, write down the range of inverse function. Range of inverse function, that is the domain of original function. For domain of original function, go back to f of x now. Domain of f function, that's argument greater than 0. Therefore, we can make 6 to the x power greater than 0. Do the 6 power. You could say x greater than 0. That means the range of inverse function will be y greater than 0. Now let's go to C. Find the value of inverse of f of g of 2. We got to do 2 steps. First step, g of 2. We log in g function, log base 9 of 2. Then your second step, we plug this one into inverse of f of x function. That means for every single x, you need to change into log base 9 of 2. Therefore, we get 6 times log base 9 of 2. Then you got to use the inverse rule to figure out the evaluation of these expressions. This 6 jump as an exponent. So we get 9 log base 9 of 2 to the 6 power. According to this inverse rule, we get 2 to the 6 power, which means 64. Let's go to number 7. Let f(x) equals 3 to the x power. G of x is a rational function. H of x is a square function. Find the g of f of 2. For composite function, always do inside first. Therefore, we get the f of 2 equals, for f function, every single x turning into 2. So we get 3 squared equals 9. Then we plug in g function, g of 9 equals, go to g function, every single x turning into 9. So 9, 3 times 9 plus 5. You will get the 9 over 27 plus 5. That's 32. This is for 1. Now let's go to 2. Do inside first, so we do h of negative 4. Every x in h function changing into negative 4, so we get square root negative 4 plus 8 equals square root of 4 equals 2. Then we go to this f function, f of 2. These two go here, equals, for every single x in f function changing into 2, so 3 squared equals 9. For number 3, that's the inverse of g of 6. Remember, when we have inverse f of a, this a equals y value. Therefore, this 6 equals y, which means y equals 6. So go to g function here. G of x, y, that means g of x equals 6. G of x equals 6. Therefore, you will set up 6 equals x over 3x plus 5. Make it over 1. Then you do cross multiply. You will get 6 times 3x is 18x. 6 times 5 is plus 30 equals x. Then you solve for this x. Minus x both sides, then subtract 30 both sides. You will get 17x equals negative 30. Divided by 17, x equals negative 30 over 17. This is the solution to number 3. Now let's go to number 4. Inverse of g of 5, which means y equals 5, or g of, therefore, for h of x equals square root of x plus 8. This h of x, that's 5 equals square root of x plus 8. Then we square both sides. We get x plus 8 equals 25. Minus 8 both sides, you will get 17. Now let's go to number 5. We need to get inverse of h of x. So use this escape button, exchange x, y. H of x, that means y. So we change into x equals square root, y change into x, x change into y. So we got y plus 8. Then we solve for y, square both sides. You will get x squared equals y plus 8. So subtract 8 both sides, you will get x squared minus 8. Then change this y into inverse symbol. You will get inverse of h of x equals x squared minus 8. For question number 5, we need to state the domain of it. So for this inverse function of h of x, we need to figure out the domain. For quadratic function, we know domain is all real numbers. But for inverse function, when you say quadratic function, you need to be very careful. you got to use the original function, that is a square root function, to figure out domain of inverse function. We know that for h of x and then inverse of h of x, we have domain, we have a range. Then range for original function will be the domain of inverse function. And domain of original function will be the range of inverse function. Therefore, we need to figure out the range of original function. Then we can get the domain of this inverse function. It cannot be all real numbers. For h of x equals square root of x plus 8. Whenever you say square root, that means greater than or equal to 0. Therefore, range for h of x, that is y greater than or equal to 0. In other words, for inverse of h of x, domain will be x greater than or equal to 0. For number 6, find the inverse of g of x and state the domain of it. Still, we got to use this escape button to find the inverse of g of x. We got the g of x equals x over 3x plus 5. First step, exchange x, y. G of x, that means y, so we turn into x equals every single x turn into y. So we get the y over 3y plus 5. Then do the cross multiply. You will get the 3xy plus 5x equals to y. We need to solve for y. Therefore, we know this is a linear equation. Keyword is isolating. So move all y on one side. You will get the 5x equals y minus 3xy. Then take y outside. We got 1 minus 3x. This is a 5x. Then we divide it by 1 minus 3x to isolate this y. So we get the y equals 5x over 1 minus 3x. Final step, we change y into inverse symbol. Therefore, we got the inverse of g of x equals 5x over 1 minus 3x. Then we need to figure out the domain of that. For this rational function, domain, we make a denominator not equal to 0. Therefore, x not equal to 1 over 3. This will be the domain of this inverse function. For b, let f(x) equals linear function, g of x equals quadratic function, h of x equals a rational function. Find the g of f of -2. For number 1, since this is a composite function, so we do inside first, f of -2. For f function, every single x turn into -2, so we get 3 times -2 minus 1. We get -6 minus 1 equals -7. Then go to this g function, g of -7. That equals every single x for g function turn into -7. So we get 4 times -7 squared minus 9. You will get 4 times 49 minus 9. You will get 196 minus 9. That is 187. Let's go to number 2. We need to figure out g of f of x, still inside first. F of x equals 3x minus 1. Then we go to this g function. You will get the g of 3x minus 1 equals 3x minus 1 go down to this g. So every single x for g function, you need to turn into 3x minus 1. Therefore, we get 4 times 3x minus 1 squared minus 9. For 3x minus 1 squared, we know that it's a plus b squared equals a squared plus 2ab plus b squared. Therefore, we got 4 times 9x squared minus 6x plus 1, then minus 9. We got to do distributive property. You will get 36x squared minus 24x plus 4 minus 9. Then we combine like terms. 36x squared minus 24x minus 5. That's for number 2. For number 3, we're looking for inverse of h of -5. We know this -5 means y equals -5. In other words, h of x equals -5. So go to this h function. We plug in. You get -5 equals 5x over 2x minus 4. So we over 1. Then do cross multiply. You will get -10x plus 20 equals 5x. Linear function, isolate the variable on one side. So we get -10x minus 5x equals -20. Remember, cross the equal sign, you need to change the sign. So we get -15x equals -20. Then we divide by -15 both sides. You will get the x equals 4 over 3. In other words, inverse of h of -5 equals 4 over 3. Go to number 4. Looking for composite function inside first. So f of x equals 3x minus 1. Then h of 3x minus 1 equals, for h function, every single x turn into 3x minus 1. Therefore, 5 times 3x minus 1. 2 times 3x minus 1 minus 4. Distributive property. Numerator, you will get the 15x minus 5. Your denominator, you will get 6x minus 2, then minus 4. Combine, you will get 6x minus 6. This will be the final answer to number 4. Now let's go to number 5. We're looking for inverse of h of x. That's escape button. Need to exchange x, y. So h of x, that means y, you need to turn into x. For every single x turning to y. So we get the 5y over 2y minus 4. Then you need to solve for y. So we got to do cross multiply. X times 2y, that's 2xy. X times negative 4 minus 4x equals 1 times 5y, that's 5y. Then you solve for y. This is a linear equation. Therefore, isolate the y on one side. Move y over here, the x over to the right side. So we will get 2xy minus 5y equals 4x. Then you factor y. You will get the 2x minus 5 equals to 4x. Then we divide it by 2x minus 5. Then you will get the y equals 4x over 2x minus 5. Last step, change y into inverse symbol. This is the inverse of h of x equals 4x over 2x minus 5. We also need to state the domain of this inverse function. For this inverse function, we know this is a rational function. Domain, we will set up denominator 2x minus 5 not equal to 0, which means x not equal to 5 over 2. That's the domain of this inverse function. For number 6, still we need to work on the inverse of g of x. Escape button. G of x, that's y. So change y into x. X equals 4y squared minus 9. Then you solve for y. Therefore, isolate the y squared on one side because this is a power pattern equation. Add 9 both sides. X plus 9 equals 4y squared. Then we divide it by 4 both sides. Then y squared equals x plus 9 over 4. Then we do square root both sides. Since the domain for g of x is greater than 0, we change the x into y. Therefore, for this y is greater than 0. This is a positive. So we got the y equals square root x plus 9 over 2. Last step, we need to change y into inverse symbol. So we get inverse of g of x equals square root x plus 9 over 2. And you need to state the domain of this inverse function. For square root function, we need to make sure inside the square root greater than 0. Therefore, I can set up x plus 9 greater than equal to 0, x greater than equal to negative 9. This will be the domain of this inverse function.